Okay, good question. Seem like you guys are doing something good. I'm gonna try to explain it. See if that makes sense. Okay, so first thing first is you need to put up information that are given. Okay, and I also believe that this question is missing a little bit something, but we'll talk about that one. So we have three 1 liter flags, so that means this is 1 liter. Okay, and that for easiness, I'll just say 1 1. I'm not gonna write unit. Okay, and then connected to 3 liter flask, so this is 3 liter. Now if you guys are trying to think too hard, you might be thinking about these pipes also have a volume. We're ignoring this. Okay, so that means total volume of all this together is actually a 6 liter. Okay, just saying. I have a feeling that this is what they're gonna say. Usually that's how you can tell. But anyway, so this 3 liter one has nothing in there. Okay, we have a temperature, so we're gonna assume the temperature is constant because these are all connected. Okay, so these gases they tell you. Okay, and then we have pressure of argon is 633 torr. Okay, pressure, this guy. Okay, gas proportionals amount, right? We know that these dot might have mean something. In this case, these dot mean how much they have. So that means this is 6 dot. That means you have 6 mole. Okay, of gas. I'm just gonna write the first one so that you kind of have an idea of which one you're dealing with. So this is 6 mole, 1 liter container. Okay, now if you go to here, you will see 1, 2, 3, 4, 5, 6. That's also another 6. And if you look here, there is a 5. Oopsie, that's not that way. It's 5. Okay, so that's what we're gonna have. Okay, so that means if I open it, the valves are open, right? The total amount of gas you're gonna have is 17 mole. Okay, so remember, gas don't really care about their different type of gas, right? So pressure doesn't really matter based on the type of gas. It's actually matter based on the how much gas you have. So mole, basically how much molecule, and then also of course temperature and a volume. Okay, so in this case, temperature doesn't change. So we have 17 mole. Okay, so 17 moles is distributed in how many volume? Well, it's distributed in 6 liter container because remember it's a total container. Okay, so I'm going to put that aside for now. This is the ratios. Okay, now I'm going to take a look at another one. Is here the argon, the one that we know. It has 6 mole of gas, and then inside there we have 1 liter. Okay, take a look. I have a question that I want you guys to think. A container. If you have a container, and if the container has gas inside there, okay, what if I'm gonna add more gas? Okay, what gonna happen to the pressure? So I'm adding more gas. What's gonna happen to the pressure? Okay, so you should say pressure increases. Okay, if you have said that, that's correct. Pressure will increase if you add more. Now I have another question. I have a container. I have a gas in there. Okay, now I'm gonna make this container smaller. So I'm gonna squish it down. Okay, so the container instead of the side, it is now this side. What's gonna happen to the pressure? You should also say pressure increases. Okay, in both cases, pressure will increases. So take a look here. 6 mole per liter. This is 17 mole per 6 liter. So that means how much mole per liter is gonna be occupied? Well, if we do the math, it's give you about approximately 3 mole per liter. Okay, this is right. So you can see the ratio. Now, think about that for instead. If you has mole per liter, mole is amount of gas containing right in the container. So if I have 3 mole per liter versus 6 mole per liter, which one is gonna have higher pressure? Okay, you should say this. 6 mole per liter is gonna have a higher pressure because 6 mole per liter is kind of like you have a lot of kid in a one small bounce house. Okay, so this is like the yes, there's more kid, but there is also your bounce house also getting bigger. So overall, this ratio decreases. So that means your pressure in here should decreases. That let you to know that it's not gonna be 633. It's not gonna also be this. Okay, that let you with these two. So which one you gonna pick? Now, if you are in a hurry, I will pick either one. But because we had time, we're going to calculate it. Now you see that it's 3 mole versus 6 mole per liter. That means I'm decreasing by about halfway. So that means my number from here should be about halfway. Okay, not exactly half, but it should be about half. So you can see 633 half is gonna to be 316.5, right? So about there. So since it's around there, it should be about 316. Now, can it be this? Yeah, but in this case, like we're saying that it's really, really close to 3. So it should be that ratio of 1-to-2 ratio. Now, if it's really far off, then yes, we can probably say it's gonna to be lower pressure, depending on how small this is. Okay. All right. That's about it. Study hard, and I'll see you guys on Monday.